Hi, my name is Mrs. Anderson. I teach chemistry, period 8.
Hi, I'm Mrs. Bart, and I teach chemistry, regular chemistry 357, and honors chemistry 68.
Flip it around. Hi, and I'm Mr. Bunnell. I teach honors chemistry during period 2 and 4, and this is the physical and chemical changes lab that we are going to model for you.
I want to point out that I have my safety goggles on. We're using Bunsen burners and a few chemicals we want to make sure don't get in our eyes. I've got my awesome lab coat on for today, and I've got my hair tied up so that there's no way it can catch on fire.
Hi, I'm going to show you how to light a Bunsen burner, which we need for station 1. The first thing you need to do is make sure you turn on the gas. When the gas is on, the valve is in line with the hose. You use the striker to spark it. There's a couple adjustments you can make. One is if you spin the stem of the Bunsen burner, it can reduce the amount of oxygen and turn it from a hot blue flame to a cool yellow flame. When it's yellow, it's not producing as much heat. If I turn it back and open up the oxygen, it makes it very, very hot. That cone within a cone right here is the hottest part of the flame. The other adjustment you can make is allowing more gas to come through. So if I, oh, that was so much that it burned it out. Ah. All right, let me get it going again. So if you add too much gas, it's gonna blow it out, but if I close it down, you can make the flame very short, or you can make it tall. Somewhere in the middle is probably the best. Okay.
All right, we're starting with station 1. Mr. Bunnell broke off a small piece of wax from a candle, and he put it in the test tube. And the next step, he's gonna hold it over the Bunsen burner using his test tube tongs. He's gonna keep holding it until that wax melts completely.
You can see that the wax is starting to melt. As I'm doing this, you're gonna wanna record observations in your data table. And you can see that as it moved from one state of matter to the other state of matter, the color also changed. So now it looks totally liquid and clear.
So make sure you record the before, during, and after observations in your data table.
Now that it's melted, I'm going to turn off the Bunsen burner and place it in a cold beaker of water. And you can see that with the cold temperature, that wax should refreeze. There it goes.
So under step 1, you can just write down your observations for what happens when that melted wax starts to cool and what it looks like as it freezes.
It's still a little bit liquid. Let me keep it in there a little bit longer. Now it appears solid again.
All right, Mrs. Bart is going to heat the bottom of the candle until the candle is soft enough to secure it to the glass plate. We're on station number 2, so you'll want to record your observations under step 2. And then once the candle is secure, she's going to light the candle.
The limitations of wearing a mask. Just letting some of that wax melt onto the Petri dish. You make observations about a burning candle, deciding if it's a chemical or a physical change, or both.
All right, step 3.
Okay, so Mrs. Anderson is going to tear a small piece of paper into tiny pieces.
You're deciding if this is a physical or chemical change.
All right, now I'm gonna light some of those pieces on fire.
As the paper catches on fire, make observations and decide if that is a physical or chemical change. Trying to get a bigger piece of paper lit. Deciding if that is a physical or chemical change and providing evidence. All right, this is station 4.
Okay, Mr. Bunnell is going to measure 5 milliliters of water into his graduated cylinder.
Remember to read from the bottom of the meniscus when you're using a graduated cylinder.
Then he's going to pour that water into a test tube. And he's going to take his scopula and measure out a little bit of sodium chloride, which is salt. He's going to stir the contents or gently mix it. He's going to put...
So you have to decide if that step is physical or chemical as it dissolves into the water.
Then we're adding silver nitrate.
And by the way, silver nitrate will stain your clothes and hands if spilled on it, so you want to be careful as you're handling the dropper bottle. Always close the lid when you're done using it. Okay, but as I add a drop of silver nitrate, make observations about what you see and decide if this is a physical or chemical change, providing evidence why. Let it settle for a little bit, and you can see that the white precipitate has formed at the bottom of the test tube. Also a little bit formed on the sides as it reacted. This is evidence of a chemical, I don't know if I should say that.